A lot has been written about how to perform the tests in presence of random effects. And the only thing that has transpired is that such a test is by no means easy. The main problem is because now the distribution of the data is rather complicated with some correlated structures coming into play. So even if you are trying to test only for the fixed effect terms and you work out the likelihood ratio, its distribution is not a nice and simple F distribution. So that is the main problem. People have suggested various approximations, and for that you need certain assumptions which are not often realistic. People have suggested alternative techniques, not using likelihood ratio at all, but certain ad hoc algebraic identity based techniques. But those things cannot be worked out in any complex problem. They are only for absolutely simple situations. So what has finally emerged is that if you have to carry out test of hypothesis in case of a mixed effects model, you go for the likelihood ratio test as before. However, do not rely on the distribution of the likelihood ratio as given by F distribution or based on any chi-square approximation. Instead, you go for parametric bootstrap. So let us see how to perform that parametric bootstrap. In step 1, what you shall do is simply fit both the null model as well as the full model. For any likelihood ratio test, you do that. Then you work out the likelihood ratio. So look at the likelihood that you get under the full model, that is you apply MLE and you get the full model, the MLE under the full model, plug them in the likelihood function, you get the likelihood. Similarly do it for the null model, take the ratio, you get LR, likelihood ratio. Now the question is, how do you check if this likelihood ratio is too high or too low? So you need to calibrate it with respect to the null distribution. And theoretically obtaining the null distribution is the difficult part of the case. Now what you do is you go for bootstrap. And this is done in the following way. You carry out a loop. In the loop, you do the following things. In step 1, you generate data from the fitted null model. So you already have fitted the null model and you generate data from this null model. Since you generate data from a fitted model, it is called a bootstrap. And since you have used the model, you are not doing it merely by resampling from the original data. That is why we call it parametric bootstrap. Now you obtain the likelihood ratio from the generated data. That is, for this generated data, you again feed the full model and null model and find the likelihood ratio. You carry out steps 1 and 2 for the data you generated in part 3a. Now you do it a large number of times. Suppose you do it 10,000 times. So at the end of step 3, you have got 10,000 values of likelihood ratio and one value of the likelihood ratio that you obtain in step 2. That is your observed likelihood ratio, and these are your generated likelihood ratios. Now what you do is you do step 4, which is basically compute the p-value as proportion of generated likelihood ratios that exceed the original likelihood ratios. So the 10,000 likelihood ratio values that you generated in step 3, they give you the behavior of the likelihood ratios under the null hypothesis. and you look at your observed likelihood ratio that you obtained in step 2 with respect to this thing, that you look at how many of the generated likelihood ratios are even more extreme than the likelihood that you have actually seen. And if this proportion is large, you will say that your observed likelihood ratio is not that extreme. Many of those things already exceed that. So you will say that I am accepting the null hypothesis. If on the other hand this estimated p-value is small, say less than 5%, you will say that you are rejecting the null hypothesis. So this technique remains the most universally accepted way of carrying out a test in case of mixed effects model.